3.3.6 Practical Application. Following are applications that craft workers encounter daily. Use a calculator and the information provided to solve each conversion problem. Be sure to show all your work. So the first one they say, find the cost of baseboard needed for the office building shown by the floor plan in figure 6. While all door widths are a standard 36 inches, do not subtract the door openings from the room measurements. Wise craft workers always allow some extra material in case somebody makes a mistake. Round the number of baseboard feet up to the nearest linear foot. The lumber company charges $1.19 per linear foot of baseboard and gives a 12% discount. At the end, add a 6% tax after subtracting the discount amount. So here's figure 6. This is an office building. We'll figure this out together. If you did this on your own and you come up with an answer that's slightly different within $15, $20, I'd say you did a pretty good job. All right. So these rooms are 28 feet by 16 feet, 23 foot 8 inches by 15 feet 9 inches. This little restroom is 9 foot 6 by 8 feet, and this foyer is 8 feet by 6 foot 3 inches. I found that by subtracting 9 foot 6 from 15 foot 9, so it's 6 foot 3. Then the conference room, this big area, you can see it has a little jog in the wall here. So it's 20 feet on the south side, it's 24 feet on the north side, and it's 32 feet on the east side and 32 feet on the west side. So I figured it as 20 and 20 and 32 and 32, and then I added these two 4-foot sections of wall at the end. So the first room here is 16 plus 16, because we're only talking about the baseboard. We're talking about the board that goes around the wall, the border of the rooms to finish off the wall. So 28 feet, 16 feet, 28 feet, 16 feet. Let's get on our calculator. So we've got 28 plus 28 plus 16 plus 16. So the first office has 88 feet of baseboard. The second office, 15 feet 9, I went ahead and rounded up to the nearest foot, 16 feet plus 16 feet. This is 16 feet, this is 16 feet, and by 24 feet by 24 feet. So, 16 plus 16 plus 24 plus 24. So, my calculator's acting up. 16 plus 16 plus 24 plus 24 is 80 feet of baseboard in office number 2. Now, over here for the bathroom in this little foyer, this little hallway, I just went ahead and treated it as one room, and then I counted this wall twice. So I said 16 plus 16 plus 8 plus 8, and then I did plus 8 plus 8. So 16 plus 16 plus, and I could say 8 times 4. I said 8 plus 8 plus 8 plus 8, and it's 64 linear feet. Now it's supposed to, let me check it again, hold on. 16 plus 16 is 32 plus another 32, which is 8 plus 8 plus 8 plus 8, is 64 linear feet. So now the big room, the conference room, is 20 by 20 by 32 by 32. Put that down here. So 32 plus 32, which is 64, plus 20, 84, plus 20 is 104. So this big room is 104 feet, plus these two 4-foot wall spaces here is another 8 feet, so plus 8 is 112. Okay, so the total, we're going to add all those together. We have 88 plus 80 plus 64 plus 104 plus 8. So we have 344 linear feet of baseboard in all of the rooms of this office building. So we'll go on to B, which says the initial baseboard cost. We're going to take our 344 linear feet times $1.19 per linear foot, gives us $409.36. $409.36. And they said that the supplier is going to give us a 12% discount. We can multiply this times 0.12, which is 12%, and then subtract that from $409.36, or we can multiply times 0.88. 88% is 100% minus 12%. So at 88%, we have $360.24. $360.24. That's the cost of the baseboard after our discount. And then it wants to know the amount added for the 6% tax. So we can take this, multiply it times 0.06, and we get $21.61. That's our tax. And then we can add that to our $360.24. So we get a total of $381.85. That's our bottom line, $381.85. Okay, very good. Now, question 2 says, using the site plan shown in figure 7, determine the percentage of the lot that will be used for parking, the building, for walkways. Round percentages off to the nearest 0.1%. So here's how I did it. I used my calculator to find the area of the lot. It's 550 feet by 275 feet. So 550 times 275 gives us 151,250 square feet for the lot. They've already given us the building at 65,000 square feet and the parking lot at 76,000 square feet. So I took 65,000 divided by 65,000. Why am I doing it this way? Hold on. I've got something better here. Here we go. So 65,000 square feet of building divided by the entire lot, 151,250. And that will give me the percentage of the building. So here's 65,000 divided by 151,250. And it's approximately 42.97. Since the 7 is there, I'm going to round up to 43%. I'm going to say that the building is 43% of the entire lot. I'll do that same thing with the parking lot. I'm gonna do 76,000 square feet of parking lot divided by 151,250. And that should give me the percentage of the parking lot. So 76,000 divided by 151,250 is 50.24. So I'm going to round to the nearest tenth and call it 50.2%. That's the parking lot. So the building is 43%. The parking lot is 50.2%. If I wanted to, I could add those together and get 93.2%. And from there, I could figure the sidewalks to be 6.8%. Or what I could do is add the two of them together. I can actually take 65,000 plus 76,000, 141,000 divided by 151,250, and it gives me, oh, I did that wrong, sorry. Let me do that again. It was 65,000 plus 76,000. I have to subtract that from 151,250. So we end up with 10,250. That's the sidewalks. So I can divide by 151,250, and it gives me 6.77. So we're going to round up to 6.8, and that's exactly what we got here. We said 6.8% for the sidewalks. When we added these two together, got 93.2%, and then we subtracted it from 100% to see what was left. It was 6.8. So that's what we have. The building itself is 43% of the lot. The parking area is 50.2% of the lot, and the sidewalks are 6.8% of the lot. Here's a quick video on the history of the metric system as I know it. Hopefully everything that I'm saying to you is true. I believe it to be true. If you find something relevant or something different, write it in the comment section. I am always willing to learn about new things. So let's take a look at the metric system, how it was developed. Okay. What I learned through books and through research is that the metric system was developed by French scientists. I don't exactly know when. I'd like to say in the 1700s. I don't know if that's true, but it's an ingenious system. It really is. So, oh boy, that's terrible. There we go. Let's see here. Here's Africa over here, and then here's the boot of Italy and the Mediterranean, and here's Spain, Portugal, and here's France. So what they did was these scientists drew an imaginary line through the Earth from the North Pole to the South Pole, and they went through Paris, France, and they said that the length of that line was 10 million meters long. That's how they came up with the measurement. So 1/10 millionth of that line is a meter. And a meter is just slightly longer than a yard. It's 39 point, I think, 58 inches or something. It's just a few inches longer than the standard yard, which is 36 inches. So that's their unit of measure, is the meter. And they divided it into 10 equal pieces. And they called each one of those a decimeter. Decimeter. Okay, that means 1/10 deci. They then made a box, and that box is 1 decimeter square, or cubed, I should say. They made this box, and each side of this cube is 1 decimeter in length, 1 decimeter. So that we know that there are 10 centimeters in a decimeter. So if we were to cut this up into 10 pieces, and then 10 pieces this way, we would have cut this side up into 100 pieces. We could do the same over here, and the same on the top, and we would have 1/1000th of this cube. We would have 1 cubic centimeter, 1 cc. And you've heard doctors talking about dosage before, and they will say, give the patient 3 cc's. That's what they're talking about, cubic centimeters, cc's. It's 1/1000th of this. This is actually a liter, a deciliter. The length of the sides are decimeter, but the volume is 1 liter. They call the volume a liter. So this cube, 1 decimeter on each side, is 1 liter. And this 1 cubic centimeter is 1/1000th of that liter. It's a milliliter. So a milliliter is equivalent to 1 cc, 1 cubic centimeter. Well, they went further than that. They took this liter and they filled it with water. They completely filled it with water, and they weighed the water, and the water, they said, weighed 1 kilogram, 1,000 grams. So they've taken a unit of length and they've changed it into volume, and now they've converted that into weight. So all of the system is tied together. It makes such great sense. It's very intelligent what they did. And then they go on to talk about temperature, and they use the Celsius scale, where 100 degrees Celsius is where water is boiling, and 0 degrees Celsius is where water is freezing. So in this way, they've tied everything together. They're units of length, units of volume, units of weight, and units of temperature, all tie together. It's a remarkably beautiful system, and I'm surprised that we're not using it in this country. We've tried several times, the government has tried to get people to use the metric system, but it's hard to get people to change when they're set in their ways. So you young students, you pave the way. Start using metric in your daily lives. Buy things based on how many liters your soda is, or how many kilograms something weighs, or how many meters long it is. When you're driving in your car, you're driving kilometers per hour, not miles per hour. Okay, well, this concludes this short video. Thank you for watching. 5.0.0 Metric and Inch-Pound Measurement Systems. So here in the US, we use the ASE, American Standard English measurements. Most of the rest of the world uses the metric system. So let's take a look at the two systems for measuring lengths, volumes, weight. So after completing this module, you'll be able to name common length, width, weight, volume, and temperature units in both the inch, pound, and the metric systems and convert them into other comparable units. List and convert between common inch, pound, and metric length units, weight units, volume units, and temperature units. It says most of the world uses the metric system of measurement. Companies manufacture and ship goods to global destinations daily. They may provide dimensions, weight, temperature, and pressure in metric values, inch-pound values, or both. Companies within the United States have started using the metric system. Many manufacturers use both inch, pound, and metric values so they can support customers from any country. So here we see that we have Celsius and Fahrenheit for temperature measurements. When you're talking about volume, we're talking about liters or gallons. The meter is what they use for length or parts of a meter, like the centimeter or the millimeter, and they use gram for weight. Measuring with metric system is simpler than measuring with the inch-pound system. Scaling metric units always involves in dividing or multiplying by tens. On the other hand, the inch-pound system requires many conversion factors. For example, 1 mile is 5,280 feet. 1 inch is 1/12 of a foot. A centimeter is 1/100th of a meter. A kilometer is 1,000 meters. It's all divisible by 10. So here are the prefixes that we use to either make the number larger or smaller. We start with the meter, and then we have micro, which is 1/1,000,000th, milli, which is 1/1000th, centi is 1/100th, deci is 1/10th, deca is 10 times, hecto is 100, kilo is 1,000, mega is 1,000,000, and giga is 1,000,000,000. Units of length measurement, 5.1.0. Inch-pound system units of length. Table 2 shows the inch-pound system's common length units along with their relationships. Many applications require breaking inches down into fractions. For everyday applications, 1/64th is the smallest fraction required. So we have inches, it's 1/12 of a foot is 12 inches. A yard is 36 inches or 3 feet, and a mile is 5,280 feet. Here's converting inches to yards. So we have 12 inches in a foot. We have 36 inches in a yard. A yard is 3 feet. 5.1.2 metric system units of length. Now they're going to use meter, and they'll either use millimeter, that's 1/1000th of a meter, or centimeter, which is 1/100th of a meter, or decimeter, which is 1/10th of a meter. This is saying a millimeter is 0.1 centimeters or 0.001 meters. A centimeter is 10 millimeters or 0.01 meters. It's 1/100th of a meter. Meter is the unit of measure for length. It's 100 centimeters or 1,000 millimeters or 0.001, 1/1000th of a kilometer. A kilometer is 1,000 meters. I'm going to try to say kilometer. I've always, my whole life, I've said kilometer, and it sounds right to me, but the rest of the world says kilometer. So I'll try to say kilometer. Abbreviate the common metric length units as shown. Millimeter is lowercase mm. The centimeter is lowercase cm. The meter is lowercase m. And the kilometer is lowercase km. Converting centimeters to meters. This is saying that there's 10 centimeters, 20, 30, 40, 50, 60, 70, 80, 90. There's 100 centimeters. That is 1 meter. A centimeter is 1/100th of a meter. So there are 100 centimeters in a meter. 5.1.3, converting length units between systems. Well, I'm not going to say you should memorize this table. I sure haven't. Be familiar with the 1 inch equals 2.54 centimeters. If you remember 1 inch is 2.54 centimeters, you can make conversions between any of the other lengths of measure just by converting into inches and then converting to centimeters and then working from there. Also know that 5 miles is approximately 8 kilometers. A kilometer is roughly 2/3 or 3/5 of a mile. So if you're ever looking at your speedometer when you're driving 55 miles an hour, you'll see that you're driving 88 kilometers per hour. So 5 miles is very close to 8 kilometers, excuse me. 5.1.4 study problems. I'm not going to do these. This is for something for you to do on your own. Check with your instructor. If you have any difficulty, write in the comment section, and I'll try to get back with you. I'll try to answer your comment if you're having difficulty with any of these. 5.2.0 units of weight. In the metric system, they use the gram. 5.2.1 inch-pound units of weight. We use an ounce or a pound, or a ton. So there are 16 ounces in a pound. So 1/16th of a pound is an ounce. A pound is 16 ounces. A ton is 2,000 pounds. Metric units of weight, it's the gram, and then they use prefixes. The milligram is 1/1000th of a gram. Gram is 1,000 milligrams. A kilogram is 1,000 grams. And a metric ton is 1,000 kilograms. Let's see here. Did you know common metric terms, the millimeter, centimeter, meter, kilometer, or kilometer, are the most common metric length units? Length units longer than a kilometer are uncommon. Scientists and precision machinists may use units smaller than a millimeter. The micrometer is 1/1,000,000th of a meter. The nanometer is 1/1,000,000,000th of a meter, and the picometer is 1/1,000,000,000th of a meter. And then they abbreviate milligram as mg, gram as g, and kilogram as kg. Metric system has a modern standard. I'm going to skip over that. Converting weight units between systems. Again, I wouldn't try to memorize this whole chart. If you can do it, more power to you. Just be familiar with a pound is 16 ounces, and a kilogram is about 2.2 pounds. When I was in grade school, they taught us that a kilogram was about the weight of a pair of shoes. They said it's 2.2 pounds. So if you know that a pound is 16 ounces and a kilogram is 2.2 pounds, then you can do your conversions from there. Again, study problems, 5.2.4, I'm not going to do the study problems. Go over it. If you have any difficulty, check with your instructor or write in the comment section. I'll try to get back with you if you're having difficulty. Units of volume. Now, volume is three-dimensional, so it's a cube. Volume is the amount of space contained within a three-dimensional space. A cube is a three-dimensional object whose sides are all the same length. So you've seen the Rubik's Cube, you know what a cube is. An ice cube. Inch-pound units of volume. A cubic inch. In order to figure out how many cubic inches is in a cubic foot, we know that there are 12 inches in a foot, but we're talking about three dimensions. So it's 12 times 12 times 12. There's 1,728 cubic inches in a cubic foot. So 1,728 cubic inches in a cubic foot. And then a cubic yard, same concept. It's not 3 cubic feet, it's 27 cubic feet. 3 times 3 times 3. So just keep that in mind, that you're working in three dimensions. Metric units of volume. They use the cubic centimeter. CC, it's 1/1000th of a liter. Cubic meter is 1 million cubic centimeters. 5.3.3, converting volume units between systems. Well, what do we have here? A cubic foot. Maybe we can do a cubic inch. A cubic inch is 16.387 cubic centimeters. Again, if you recall that there are 2.54 centimeters in an inch, then we can do 2.54 times 2.54 times 2.54, and we get 16.387 cubic centimeters in a cubic inch. Study problems converting volume units. Again, if you don't have that chart, I'm not sure exactly how you'll be able to do those conversions. There are two main scales when it comes to temperature, Fahrenheit and Celsius. And Celsius they've set the freezing point of water to be 0 on the scale. And the boiling point of water is 100 degrees Celsius. So there are 100 degrees difference between boiling and freezing of water. The way I heard the story, I don't know if this is true, old Fahrenheit wanted to make his from 0 to 200 degrees Fahrenheit, but he made a mistake and used salt water. That's the story I got. I don't know if there's any truth to that or if it's an old wives' tale. That's why fresh water actually freezes at a warmer temperature than salt water. It freezes at 32 degrees Fahrenheit and it boils at 212 degrees Fahrenheit. So there's 180 degrees difference between the freezing point and the boiling point of water on the Fahrenheit scale. That'll come into play later because we'll use that 1.8 as a multiplier to convert from Fahrenheit to Celsius. If we're going from Fahrenheit to Celsius, we'll subtract 32 and and then we'll divide by 1.8. If we're going from Celsius to Fahrenheit, we'll multiply times 1.8, and then we'll add the 32 at the end. There are two other scales, the Kelvin scale and the Rankine scale? Rankine. I'm not going to go into great detail, but what they're doing is they're making a scale that starts at absolute zero, and absolute zero is negative 273 degrees on the Fahrenheit scale. So it's an extremely cold temperature, and it's theorized that at absolute zero, all motion stops. I don't know that it's ever been proven, but here are your two formulas. I think it's a good idea for us to highlight those in our book. To convert Celsius, it equals 5/9 times Fahrenheit minus 32. So in order to go from Fahrenheit to Celsius, you subtract 32, and then you multiply times 5/9. I say just divide by 1.8. Same with converting from Celsius to Fahrenheit. Your Celsius reading multiply times 1.8 and then add 32 degrees. So from Celsius to Fahrenheit, you're going up and up. So you multiply by 1.8 and then you add 32. Fahrenheit, you go down and down. Subtract 32, divide by 1.8. Digital thermometers. Thermometers with digital readouts can provide temperature readings in both Celsius and Fahrenheit. Many analog thermometers have dual scales as well. The unit on the top is a digital temperature probe. Okay. Study problems. I'm going to leave those to you to do the conversions. And here's the section review. It says, when converting from a larger metric number unit to a smaller one, the decimal point must move to the right. It moves to the right. Weight is the force that an object exerts on the surface due to its mass. And I believe it's weight. What is it? Mass and density? I don't remember seeing that one. I must have skipped over it. The cubic meter represents a three-dimensional object equivalent to a cube that measures 100 centimeters by 100 centimeters by 100 centimeters. There are 100 centimeters in a meter. So that's a cubic meter. On the Celsius temperature scale, the difference between freezing and boiling is 100 degrees Celsius. Okay. This number 2, weight is the force that an object exerts on a surface due to its mass. I want to say in volume, but I thought they replaced the word, they replaced the word weight with volume. So I think it's mass and volume. Okay. You know what? Let's just go back through the book. Let's take a look here, and we'll weight measures. Let's see if they tell due to its mass. Okay, weight is the force that an object exerts on a surface due to its mass and the Earth's gravity. There we go. That's the answer we were looking for. Due to its mass and the Earth's gravity. So weight is the force that an object exerts on a surface due to its mass and the Earth's gravity. So, yeah, that makes sense because it'll weigh different if it's on the moon. Okay, very good. We'll move on to the next section.